This is the existence of two or more compound in brackets known as isomers with the same molecular formula but different arrangements of their atoms is known as isomerism. Okay. Then, compounds or molecules with the same molecular formula but different arrangements of their atoms is called isomers. Please take notes. The existence of two or more compounds with the same molecular formula but different arrangement of the atoms is known as isomerism. While compound with the same molecular formula but different atoms arranged in place is called isomers. Let's quickly look at the types of isomers. There are 6 main types of isomers. 6 main types of isomers. 6 main types of isomers, or the word isomerism can be classified into 6 main types. 2 main types rather. 2 main types. One, we have structural isomerism and stereo isomerism. Okay. There are 6 types of structural isomers. 1, we have chain. 2, we have positional. 3, we have functional group. 4, we have metamerism. Next, we have tautomerism. And the last, we have ring chain isomerism. There are 2 types of stereoisomers. We have geometric isomerism, and then we have optical isomerism. Okay, so isomerism is structural or stereoisomerism. So structural isomerism or constitutional, we also call it constitutional isomerism. Okay, there are 6 types of constitutional: chain, positional, functional, meta, total, and the ring chain. So these are on that. So let's take it one after the other. Structural isomerism. What is structural isomerism? We want to pause the video and answer the question. Structural isomerism. Okay, the isomers. Here, the isomers have the same molecular formula but different structural formula. That is structural isomerism. Most time when we ask to define isomerism, we define structural isomerism, not minding that is not correct. So this is, the isomers have the same molecular formula but different structural formula. The same molecular formula but different structural formula. That is constitutional isomerism. There are 6 types of these types of structural, types of structural isomerism. Types of structural isomerism. One, we have chain isomerism. Chain isomerism. So in chain, the isomers or the isomer have the same molecular formula, but different chains. The same molecular formula, but different chains. Then belonging, different chains, but belongs to the same homologous series, and then having the same functional group. Okay, I repeat, the isomers have the same molecular formula, but different chains, but belong to the same homologous series and having the same functional group. So, structural isomer of that nature are called chain. I'll give examples. Example. A hydrocarbon with molecular formula C4H10, will have two possible chain isomers, namely one to have a normal, since it's 4, a normal butane, and 2, a 2-methyl propane. Okay, so that is it. On that note, we're looking at C4H10. Okay, what is normal butane? Is a normal alkane. All straight chain alkanes are normal alkanes. And since I have this carbon in straight chain alone, so with whatever name of this alkane I'm going to obtain is going to be normal straight chain. Okay, so let's give every carbon here 4 bonds, and H is how many there? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is not just butane, but N-butane. Okay. The chain will be so differ in this organic compound, whereby instead of having this carbon all in straights, I have some bent somewhere around here. Okay, see the point now. How many carbon atoms are there? There's C4 is C here. H is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4, H10. Okay, and this one is what? 1, 2, 3. So the long chain is 3, having this methyl attached to position 2. So this is 2-methylpropane. So what it does appear here is that the 2-methylpropane and normal butane are isomers. Yes, or I can say call this isobutane. That's the trivial name, isobutane. Okay, so these two are isomers. Why are they isomers? They have the same molecular formula but different structure. So this occurs when the isomers have the same molecular formula. Okay, different chains, but they must, the criteria for this isomer that they must belong to the same homologous series and must have the same functional group, but they tend to have different chains. So that is chain isomer. Okay, let me give you another example of that. Let's also be increasing the number of carbons. So if this butane should have 2 possible isomers, how many isomers are there in pentane? Okay, let's see now. Still on chain isomer. Still on chain isomer. Chain isomer. Okay, C5H12. Okay, let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, this is, since it's straight chain, so I'm going to call it an pentane. Okay, so it's not a normal alkane. So let me start to reduce the number of carbon in long chain to sort of 5. I have 4, maybe this is the 5th one as branch. Okay, let's check it. Same number of carbon atoms, C5H12. Okay, so it's normal pentane. This one is 2, 1, 2, 3, 4. 2 methyl butane. Okay, that's viewers. Okay, now in the next case now, I can have the chain cut into 3 now. So maybe 4th one here and then 5th one here. I have the same number of carbon atoms, the same number of hydrogen atoms. So what is this? This is going to be what? 2, 2. Because the material is in position 2, 1, 2, 3. 2, 2 dimethyl what? Propane. Okay, so that's it. So in that case, this particular hydrocarbon pentane, this is pentane. So the 2 possible isomers of pentane is, sorry, the 3 possible isomers of pentane is what? Normal pentane, 2 methylbutane, and 2 dimethylpropane. So this particular organic compound will tend to have possible isomer, 3 possible isomers. What if I increase the number of carbon atoms to be C6H14? Okay, that is hexane. So how many possible isomers will be obtained from hexane? You can pause the video. I want to find out how many isomers. So let me do it quickly. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, let me cut here. So this one is normal hexane. Let me cut from here. So I have 1, 2, 3, 4. Okay, 5. And then here will be 6. Okay, so in this case, I have next one is 2 methyl 1, 2, 3, 4, 5 pentane. That's the second name. I can shift this alkyl group to have different chains now. Still on 5, 1, 2, 3, 4, 5. I can have here now. So I have different names now. So this is what? 3 instead of 2, 3 methyl pentane now. Okay, so in this case now, I may want to shift to this side, but it will still look like this. It will still be 2 methyl pentane. So there's no possibility of shifting the body. I can still cut the chain into 4. I have the 5th one here, and I have the 6th one here. Something like this can happen. Okay, in this case, I have another chain, which is what? 2, 2, sorry, let me write it. 2, 2 dimethyl butane. That's what it is. Okay, I have the effects. Okay, how many now? 4. I can go on and say changes. I can still have 1, 2, 3, 4. Maybe here 5, and here 6. I think after this you can have more, and this, and this. So this is 2, 3 dimethyl butane. Let's see how many I have now. What if I try to bring this one here, keep this one here? It will still be 2, 2 like this. Okay, and at this point, what if I decide to cut the chain into 3 and C4 here, C5 here? I cannot add here and here. So I don't think at this point we cannot have more than this as possible isomer of hexane. So hexane possible isomer is number 1, number 2, number 3, and then number 4. And then number what? 5. So these are possible isomer of hexane. Hexane has 5 possible isomers. Hexane, 2 methylpentane, 3 methylpentane, 2, 2 dimethylbutane, and 2, 3 dimethylbutane. Okay, for sake of convenience, without going through all these hurdles to find a number of possible isomers, we can use this formula to find chain isomer. Suppose I want to find the possible isomer of butane. I can use this formula to find a number of formula for finding possible chain isomers. I can use 2n minus 4 plus 1. That's it. So how many number of carbon atoms are there in butane? Just 4. 4. So this N here means number of carbon atoms. So in butane I have 4 minus 4 plus 1. This is 2, 0 plus 1. 2 raised to the power 0 is just 1 plus 1. So in butane there are 2 possible isomers. Okay, that is normal butane and 2-methylpropane. Okay, for pentane like this, we're able to have 3 possible isomers. Yes. So how many number of carbon atoms are there in pentane? 5. So I can decide to have this place 5. 5 minus 4, 1. 2 raised to the power 1 is 2. 2 plus 1 is 3. So that is 3. 1, 2, 3. How many possible isomers are there in this one? We are able to obtain 5. Let's see if it can be 5 in this formula. Here the number will be how many here? 6. How many here? 2. How many here? 4. How many here? 5. This is 5. But this cannot tell you the exact name. They just give you the number without actually ascertaining the names, the IUPAC names of these isomers. Remember, as the number of carbon atom increases, of course, the number of possible isomers should also increase. So, if you are calculating the number of isomers from C1 to C3, all have possible isomer of 1. There is no isomer more than 1 isomers in those organic compounds from C1 to C3. But from C4 to C8, okay, from C4 to C7, isomers can be obtained using this formula. Okay, using this formula. Then from C8 to C9, isomer can be obtained using this formula. So you just change this narrative. 2n minus 2 raised to the power n minus 4 plus 2. That is, the number of carbon is from C8 to C9. So that's how to use it. So that is the only message. So from C4 down to C9 is where this formula is. But meanwhile, from this to this is 2n minus 4 plus 1. From this to this is 2n minus 4 plus 2. So you can apply the formula and find out the possible number of isomers from C4 to C7, from C8 to C9. And then C10 does not have any formula, but you can obtain it by adding all the isomers from methane is 1, ethane is 1, propane is 1, butane is 2, pentane is 3, hexane is 5. You add all these isomers till the 9th one. Anything you have there is going to be the number of possible isomers of the cane. That is C10, H10 in terms of chain isomers. Okay, let's look at the second type of structural isomerism, which is positional isomer. Positional isomerism. Okay, here the isomers have the same molecular formula, but different structural formula, whereby functional group appears in different chain on the carbon skeleton. I'll repeat. These isomers have the same molecular formula with functional group found on different location on the carbon skeleton. Okay, so I'll give you examples. How many positional isomers will be there in an organic compound with this molecular formula? C2H4Br2. How many positional isomers will be there? The bromine there is the functional group. Okay, so let's see how many possible isomers will be there. 1, 2, H4. 1, 2, 3, 4. And you have bromine here. 1, bromine here. 2. Okay? Okay, so that is it. So, but if I try to change the bromine to be on the same position on the carbon chain, okay, so it's the only bromine that is being changed. Bromine is being found in different locations. So, How many possible isomers can you obtain from this organic compound? How many? The first one is 1,2-di-bromo-ethane. And the next one is 1,1-di-bromo-ethane. Okay, what if I choose to put these two on this point? It is still a 1-1. So a hydrocarbon with this molecular formula will only have 2 possible isomers. So how many isomers will exist here? 2 possible isomers. 2 possible positional isomers is possible for this. What if I increase the carbon to C3? Maybe this time C3H6Cl2. How many possible isomers will be there? We'll find out. 1, 2, 3. Okay, we'll start with keeping chlorine in the same location. The second one, we can put chlorine in this point. Is there any possibility that we can have chlorine at this point and this point? Yes. And then we can have chlorine at this point and this point. Okay. So how many possible isomers? The first one is 1,1-dichloropropane. Second one is 2,2-dichloropropane. Fourth one is 1,2-dichloropropane. And this one is what? 1,3-dichloropropane. So it does appear that this organic compound will have just 4 possible isomers. So how many isomers will be obtained from this organic compound? 4 possible positional isomers are obtainable from this organic compound. 4 possible positional isomers will be obtained. Now, I'll give you the last example here. How many possible positional isomers will be obtained from propanol? Propanol. How many possible will be obtained from propanol? Propanol is C3H7OH. How many? Let's go. 1, 2, 3. The functional group is OH. Let me keep OH here. H7, 6, 5, 6, 7, OH. Okay, this is 1, 2, 3. First one is propan. 1 O. As the position of this one must be mentioned. 2, 1, 2, 3. What if I shift this one here? Okay. Okay, this is 1, 2, 3. We have this as propan 2O. Okay? And what if I shift this in here? To give it lowest possible number, I have to start from the number 1. So it is still propan 1O. So how many possible isomers can be obtained from propanol? 2 possible positional isomers. So this is on positional isomerism. So let's look at the functional group isomerism. Functional group isomerism, that's another type of structural isomerism. Functional group isomerism.